Hi everybody. To get started with this lesson, we want to do a quick review of linear equations, equations that graph to be lines. So the equation of a line is in the form y equals mx plus b, where m is your slope and b is the y-intercept. I remember how to use this to graph because for me, b means begin. So we always start graphing at the y-intercept, and then we use the slope to move from there. So it's kind of a little word beginning letter trick to help you remember how to use the b value to begin and the m value to move. Slope measures the steepness of your line. It's the rate of change of y as the x changes by 1 unit. So a lot of times we like to divide that slope all the way down so that the denominator is a 1 in order to really interpret what it means. However, when we're graphing it, we like to look at it in its fractional form still. The interpretation structure, because sometimes you will need to interpret a slope. You'll have to put context behind it because, again, with statistics, none of it matters unless you can explain what those values are telling you in context. So what we get is as the x value, whatever that is in your context, as that increases by 1, we expect the y value to either increase or decrease by the slope, by whatever value you have there. And you just basically fill in those blanks with the context from your question. But if you always use that structure, then you'll always have it right. The y-intercept is where your graph crosses or touches the y-axis, and that is where the x-coordinate is 0. So what's really important is that all y-intercepts have the format 0, comma, a y value, or 0, comma, specifically, we call that one b. Now there are a lot of different words to describe the next two definitions here. So the explanatory variable is just another word. It's more of the statistics word for your x variable. Sometimes it's also called the predictor or the independent variable. Those are all ways to say the x value. The response variable is then your y variable. It's the predicted variable or the dependent variable. It's important to know whether a linear equation has positive, negative, 0, or undefined slope. So I've got some visuals over here and also some explanations. So when you have positive slope, as your x increases, y also increases. So if we look at our images, the uphill, the positive slope over here, is as we go farther and farther on the x, as the x's get bigger, notice so do the y's. Negative slope means as your x increases, your y actually decreases. So the farther we go out in the x direction, the smaller those y values get. Very fun to do on a bike or on a snowboard or something like that. Now the next two are the ones that get confused a lot. They get put backwards. There is a big difference between a slope of 0 and an undefined slope. 0 is a number. 0 is a value. Undefined does not exist. So these are different things and you can't interchange them. For 0 slope, as the x increases, y is constant. So that would be this example here. As the x's get bigger, notice the y value doesn't change. The y value is just locked in to whatever this y value is. And it stays that. So x's keep getting bigger and bigger, but y doesn't move. There is a y value, it just never moves. Okay, so it's like walking on flat ground or riding a bike on flat ground. There's 0 slope. It's probably 0 fun to do most of that. Now, undefined slope means x does not even change. There is no change in x. So that is this terrible situation over here where notice the x value is actually the one that's locked in. We're locked in somewhere here on the x-axis. The y goes up and down forever, creating this vertical line. So it's undefined. It's a very bad thing to happen if you are riding a bike or you are walking and this happens and you go straight up and down. That's not good. That's undefined. So recall the slope formula. This is something you should have studied before. To find slope, we find the change in the y direction over the change in the x direction, also referred to as rise over run. So if we think about it this way, when there is no change in x, the denominator equals 0. And that is why we get undefined slope, right? When there's no change. So the values are the same. For example, maybe this x value over here is 2. So maybe my x's are all 2's. So I get 2 minus 2, or I get 0 in the denominator of a fraction. That's why it's bad news. Okay, so a scatter plot is a graph where two numerical variables are graphed to show a relationship. It's a graph with only points. So when we go to make scatter plots are just points scattered on the coordinate axis. And then there's what we call a regression line. That is a line that is drawn through the scatter plot. It comes closest to all the points, and it is a tool for making predictions or estimations about future observed values.